So you guys, I wanted to clarify something really quickly, okay? So we, like this whole order matters or order doesn't matter thing is a little bit confusing. So let's just take this scenario again, right here. Let's just take these two cases. This means I have 6 people, okay? This is what I mean. In this case, I'm putting 6 people in 2 different slots, right? That's what this 6 times 5 is coming from. That's why I have 30 here. Now, what does this mean? That means I have 6 people. I'm going to just choose 2 randomly. Choose 2 randomly, okay? That's why it's 15. So if I chose A and B, it's the same thing as choosing B and A. That's why I can't count them twice. But in this case, this is a situation when I use NPR. It's like I'm trying to choose 2 people to put into order. I don't know if I clarify that, but hopefully as we do more situations, you can kind of decide which one to use when, okay? All right, so let's go on to part 3. Part 3 is about the phone numbers again, okay? I think we kind of did it, but we're going to do a little bit more with it. So part 3, telephone problems. So you remember, look at the types of problems. That was the outfits problem. This one was a telephone problem. Call me baby. Do you remember how we talked about the number of ways that you can call me, right? Okay, so let's do this. If you don't understand any of this, you can come back on Monday and ask me, okay? So how about let's go any situation. Let's go through all these situations, okay? How about if I told you you can put any numbers here from 0 to 9, okay? No restrictions. How many digits can you dial until you get Miss Chang's number? You're right, we discussed this already, right? There's 10, all the way to 8 times, right? So it's going to be 10 to the 8. So there's 8 slots that we can fill with 10 different digits, okay? That's no restrictions. Now I'm going to start putting some restrictions. The first and the third digits are definitely 2s. Oh my God, Miss Chang is giving you some hints to her phone number. That means I have this, right? The first and the third has to be 2s. These have to be 2s, okay? So now what happens? How many digits are possible? But I'm telling you that these are the only 2s, right? So how many digits are possible here? Think about it. I used 1 from 10, so I only have 9 here. And how about here? 9, 9, 9, 9, because other ones could repeat. So I have, what's the answer here? It's going to become 9 to the 6th power. Because 1, 2, 3, 4, 5, 6. That means 9 to the 6th. And you guys, that's significantly less than this guy here. If I gave you those hints, you could have called me less. You could have got my phone number in less amount of calls, okay? Now let's go here, C. None of the digits repeat. So you guys, look, none of the digits repeat. I'm starting over now, okay? Starting refresh. None of the digits repeat. That means it's, how many choices do I have here? I could choose from 10, but I could choose from 9, 8, 7, 6, 5, 4, 3, right? Why? Because I have 10 choices here, but I used 1, so I can't repeat that, so it's 9. I can't repeat the next one either, so it's 8, and so forth. So that's why this is n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus r plus 1. Why is this n minus r plus 1? Because I'm trying to tell you that this is 10p8. Remember, r is 8, right? So we're doing all the way until r plus 1, which is equal to, in our case, n minus 8 plus 1. Okay, so in our case here, that's going to become 10 factorial over 10 minus 8 factorial, right? If I use NPR. So it's going to be 10 over, oh, sorry, not 10. It's going to be 2 factorial here, right? So it's going to be 10, 9, 8, all the way to what? 3. That's the same thing as that right there, okay? Okay, hopefully, okay. If you have any issues with that, let me know, okay? Because this is 10 factorial over 2 factorial, right? It's just simplifying a factorial, really, okay? Let's go here. D, the last 4 digits have to be less than 2,000. The last 4 digits have to be 10. What's that mean? That means it has to be, oh, sorry, a little extra here. You guys, this right here, these 4 have to be less than 2,000. That means, how many choices do I have here? It could either be a 0 or 1, right? Because it has to be less than 2,000. So that means I have how many choices? 2. 0 or 1 only. How about the other ones? 10, 10, 10, 10, because there's no restrictions on the other ones. That means this guy is going to be 10 to the 7th power times 2. That's your answer. And you can just calculate it if you want, but you can leave it like this right now for the homework, okay? 10 to the 7th times 2. And it's 0 or 1 only, because I have to be less, this quantity here has to be less than 2,000. Okay? How about this? Both sections of the number are even. That's interesting. Both sections even. That means, well, which digit is the only one that matters, right? So anytime you want to stop and think about it, you should just stop the video, okay? Think about it, you guys. Both sections are even. That means only the last digit counts. They have to be even. So how many even digits are from 0 to 9? 0 is even, okay? So it's going to be 5 and 5. Because 0, 2, 4, 6, 8 are even. And then the other rest, no restrictions. You got it, okay? All right, 10, 10, 10, 10, 10. You multiply all that. That's not a minus sign, that's a hyphen, okay? So it's going to be 10 to the 6 times 5 squared. That'll be your answer, okay? Those are the telephone kind of problems. But of course, it doesn't have to always be a telephone, okay? All right, let's take this out. All right, let's move on to part 4, part quattro, bookshelf problems, slots, okay? Again, slots, right? Now, book slot problems. So this is where you use a lot of permutation, okay? In how many ways can we arrange n number of books? As we talked about, it's n, right? N factorial, okay? So let's go like this. This is permutation. Let's talk about girls and boys here. I think you guys might recognize them. It's a little dark in this picture. Let's go here. Girls and boys. And this is like number 24 in your books. In how many order of ways, okay, can 9 girls and 7 boys walk through a doorway single file, okay, without any restrictions, or ladies first and then boys follow? Okay, let's think about this. Now, if I have no restrictions, I have 9 girls and 7 boys. If I have no restrictions in a single file and how they can walk through the door, right? It doesn't matter whether you're a boy or a girl. So they could all be mixed in together. So what do you think that answer is here? How many ways can they walk through a doorway single file? How many people are there total? 16. So 16 different ways. In fact, 16 factorial different ways. I mean 16! Okay, different ways. All right? But now we have a restriction here. Ladies have to be first, and then the boys follow. So 2 slots. Ladies and boys, okay? Well, how many? But within the ladies, right? Aren't there 9 different ladies? So how many different ways can ladies walk in? You're right. It's 9. How about the boys? 7. And then you multiply them together. And that's the number of different ways. Okay? All right. So you're right. NPR. What should I use? That's going to be the problem. But that's just a lot of practice that you're going to need. Okay? Let's move on. Okay. Now let's do another problem like this, but with couples. Okay? Now we have, this one's a little bit more interesting. Okay? I have 5 couples have reserved seats in a given row for a concert. So you know how couples always want to do things together, right? Always. In how many different ways can they be seated if each couple insisted on sitting next to each other? 5 couples mean how many people, guys? You're right? 10 people. Okay? 10 people. And if they could sit however they want without any restrictions, what would that be? By now, you should know that's 10 factorial, right? But now, they insisted on sitting next to each other, guys. They want to sit next to each other. They really, really want to. So I'm going to do this 2 ways first, okay? Okay. Obviously, I hope that you thought instinctively it's going to be used with slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now, remember, couples have to sit next to each other. How many people are there, though? There's 10 different people. But you guys, if I chose one, let's say this is Kelly. Who does Kelly always want to sit next to? You better believe it. It's only one person available. Because that's my only lover. I swear to you. And it's Mr. Van Moppes. So that's why it's 1 there. Okay? Remember, that's 1 couple gone. So tell me, how many couples are left? About 4 more couples are left. So how many people could sit here? How many possibilities? Let's do now Mr. and Mrs. Bunting. Let's say Miss Bunting wants to sit here. How many people is she chosen from? You're right, 8. But now, who does Miss Bunting always want to sit next to? Mr. Right? You get the flow? What goes here? Did you say 6? Because this is going to be, like, let's say this is Mr. Collins. Miss Collins could be only one person. Miss Skates. Right? And what goes here? That means only Mr. Skates. Or Mr. Steinbach. Okay, sorry about that. And then we have one more couple left. That's why it's 2. And then the other couple's this couple's partner, which is 1. Now, if this is really difficult for you to understand, I'm going to show you a different method, which I like better. Okay? That's 3,840 different ways. Can you believe it, you guys? There's 3,840 different ways that 5 couples can sit in a given row. That's incredible, right? It's pretty cool. Okay, let's do it this way. I like to do it this way too. You guys ready? Now, I have 10 people to choose from. I'm going to choose one person to sit in the first seat. But that means I have one person to choose from to match that couple. That's 1, choose 1. I have 8 people left because I've already used up 2 people. But I'm going to choose one person to sit in the third seat. But that person could only sit from one person because that's their couple. 6 people to choose from because I've used 4 people already. I choose one person to sit here. The only person that can sit next to is a significant other. Until 2, choose 1, 1, choose 1. So if you want to think of it as a choosing way, that's okay too. Okay? Which is 3,840. Okay? See if you understand why this would also work. Are you ready for this? This is going to blow your mind. So second way, I guess the third way is good too. Watch this. There's 5 factorial ways that 5 couples can be sitting. Right? They can sit, right? They can sit next to each other. 5 factorial different ways. But you remember, within, 5. This could be couple number 1, couple number 2, couple number 3, couple number 4, couple number 5. So 5 different ways. But you know, it could be A, B, C, D, E, F, G, H, J, K. But can't they be sit at B, A, D, C, F, E, H, G, K, J? They could be sitting like that, right? That's why we have to do 2 to the 5th. Because in each of these, there's also 2 different ways that they can be sitting. That's why it's 5 factorial, 2 to the 5th. And you know what you get? You get the same answer of 3,840. Amazing, right? Amazing, okay? So if you want to think of it this way, you can, or this way, or this way. They all work, okay? Let's go on to part 5. Part 5, Kelly problem, which is also using slots, okay? What is the number of distinguishable permutations of Kelly and Mississippi? So you guys, that means LL. If you spell out a name with L-E-K-E-L-L-Y, but you want to rearrange it, that L and that L is, if this is L1 and this is L2, it doesn't matter because the word is the same. That's what distinguishable permutations mean. So we have to count those out. So Kelly has how many letters? 5, right? It's going to be 5 factorial over 2 factorial. Anytime there's a repeated letter here, you got to divide that out. 5 times 4 times 3, which is going to be 60 different ways that we could rearrange Kelly. That means if I have K-E-L-1, L2, it's the same thing as me saying Kelly, L2, L1. This L and this L, they're the same word. So I don't want to count it twice. Okay, that's why I'm dividing it out. Okay? Let's go here. Mississippi is a classic one. Mississippi has how many letters? 11 letters. 11 letters, okay? That means it's 11. Now, how many of these letters repeat and which letters repeat? The I, the S, and the P. So there's 4 I's, divide it out. There's 4 S's, divide that out. Because remember, S1, S2, S3, S4, it doesn't matter how they are spelled out. They're all the same word, and 2 P's. That's why we have to divide that out. Okay, and you'll get some answer here. Try with your calculator, okay? Make sure you're careful with the denominator and numerator, okay? All right. Please move on to part 3.